Question 5. A jury of 12 people is to be selected from a panel of 8 men and 8 women. So you want to select 12. In the initial part of the question, part A, there is no recommendation that it has to be how many men or how many women. It can be any random selection. So basically we treat that as 16 choose 12. Okay? And remember, well, you can do it on the calculator. So 16 choose 12 is 1,820. Nice, easy, 5 marks. Okay, the second part of the question says, find the probability that the jury selected has more women than men. Okay, so more women than men. So the probability that it has more women than men. Well, we've already just said the number of ways of choosing 12 people is 1820. So now we're going to see the number of ways of choosing the 12 people when there are more women than men. Okay, so how many ways are there of picking the selection when there has to be more women than men? So the jury is made up of 12, so we could have 8 women and 4 men. We can't have 9 women because there's only 8 women there. We could have 7 women and 5 men. If we have 6 women, we would have 6 men, so we wouldn't have more women than men. So they're the only 2 options. So how many ways are there of picking 8 women and 4 men? That's 8 women, so it's 8 choose 8, and so multiply by 8 men choose 4. 8 choose 4. Or we could have 8 choose 7 women, 8 women choose 7, and 8 men choose 5. So choose the woman, choose the man, multiply them together, choose the woman, choose the man, multiply them together. And it's that or that. That's the number of ways of choosing the 12 so that there are more women than men. So that's how many, the number of ways of choosing them so that there are more women than men. We need to put that over 1820 to get the probability that we select more women than men. So 8 choose 8, right, let's just, 8 choose 8, I'll just write down the numbers just for speed. That is 70 plus 448. So that totally gives you 518. And the answer then is going to be there's 518 ways of picking more women than men out of the total number of ways of picking the jury. And your probability is 518 out of 1820, and that is 0.284615. Okay, again, that was a very straightforward one. Shouldn't have been too much problem in that. Any questions, you can let me know. Right, the last bit. Okay. A teacher says to her class of 23 students that there is a greater than 50% chance of 2 or more of them having the same birthday. Do you agree? Okay, so we want to look at the probability that 2 or more have the same birthday. Now, that could get very complicated very quickly unless you think about it like this. 2 or more having the same birthday is the same as saying 1, which you can't really have, so none of them. If we take 1 minus the probability that none have the same birthday. Okay, now think about it. The probability that 2 or more have the same birthday, that could mean 2 of them have the same birthday, 3 have the same birthday, 4 have the same birthday. We have to consider all those options. Or we say it's 1 minus the probability that none of them have the same birthday. Because if If it's not a case that none of them have the same birthday, then it's definitely a case that 2 or more of them have the same birthday. So we need the probability that none of them have the same birthday and subtract it from 1. So first of all, what's the probability that none of them have the same birthday? Okay. Well, let's take the first one. The probability that the first one has his birthday on the 1st of January is 1 out of 365. Now, the probability that the next one has a different birthday is going to be 364. What's his probability? It's going to be 364 out of 365, because you can pick any other day for him. Now, the next student, their birthday will be 363. His choice is, he has a choice out of 365. He could be any one of 363. The number of ways of picking the next one's birthday will be 362. This is allowing for the fact that they can't have the same birthday. This is going to go the whole way down, okay, for 23 students. Now that's for the 1st of January, or we could have that this guy is on the 2nd of January, which will also be a 1 over 365, times that, times that, times that, times that again, or the next date, the 3rd of January. So hopefully you can see that there's going to be 365 of these options here. So what we have is the probability that none of them have the same birthday is 1 over 365 times 364 over 365 times 363 over 365 all the way down. Okay, so we're going all the way down to 27 away from 365. So 340, is it down to 343 out of 365? So 343 out of 365. Sorry, not 27, 23 students. Okay. So for the 23 students going back, that's the 23, 20, the 1st, 2nd, 3rd, all the way down to 23. And we have, remember then, we have 365 of that option, because it could be any one of the first persons could be any one of those days, and the others would have to be different. Okay. Now another way of thinking about it is, well, let's just leave it at that first. So when you multiply that out, you get 0.492702. 0.492702. Now that's the probability that none of them have the same birthday. So 1 minus that is going to be the probability that 2 or more of them have the same birthday. And that is greater than 50%. Okay, so the teacher was correct. All right. Now, the other way of thinking about it, if you like, is you can say, you could, rather than having the whole adding of the 1 over 365, you could just say, well, the first guy's birthday can be any of those days. So you've 365 ways of picking his. So 365 out of 365. The number of ways of picking the second one is 364, because you've got one less. 363, 362. And then you don't need this multiplier, you just have 3 6s. It gives you the exact same answer, 365 over 365, 364, and all the way down to 343. So again, just on that one, the number of ways of picking the first guy's birthday is 365 out of 365. The number of ways of picking the next guy's birthday has to be 364, because it can't be the one that this guy was. The next one is 363, all the way down, and there are 23 students. Okay, so that gets you all the way down as far as the 343. Okay, that's that question done.